The Bad Vibes programme features an acoustic scientist, Professor Trevor Cox. He has developed a website to carry out research on the world's worst sounds. It also looks at different methodologies in his work. The programme addresses several key areas of the How Science Works curriculum: the collection and analysis of scientific data, quantitative and qualitative methods, and the role of the scientific community in validating changes in scientific ideas, for example, through the peer review process.
Well, we had to design a website to put these sounds on so people could go on, press play, listen to these sounds and vote on how horrible they are. And the interface had to be very simple and very obvious to use, because people couldn't ring me up. They couldn't say, "Oi, Trevor, what do I do next?" It's all very confusing. So the website design was very important. The reason to use the internet is so we could get lots of people, lots of subjects voting on these horrible sounds, but also to get lots of people from lots of backgrounds. There's not many methods which enable you to test people in different countries and of different ages, and therefore the internet had to be used.
Professor Cox's film is a very good opportunity for us to distinguish with students between quantitative and qualitative data. The Bad Vibes website investigation generated a massive amount of quantitative data. The website did not collect any qualitative data, and Trevor very carefully explains how follow-up work on the worst sounds, i.e. why we think some sounds are worse than others, now that he's got some data about which are the worst sounds, would have to be done in a qualitative fashion.
We can't ask people how do they feel about the sounds on the website, because with 1.5 million votes we wouldn't know how to analyse it. It's a big problem. So the website is very quantitative. We just get people to rate the sounds. We say just score this on a scale of effectively 1 to 6, because we can then deal with the data that we get. And in setting up this kind of experiment, it's really important to think through the data analysis before you set the experiment up.
In Bad Vibes, Professor Cox talks about several different areas of his research. Some of his work looks at the effectiveness of sound insulation products. Because this work is based in the laboratory, the choice of methodology is very different.
He also looks at how you will use different methodologies depending on the type of research you're carrying out and how you can make that research reliable. So, for example, in the Bad Vibes website research, the reliability was addressed by the huge sample size, 1.5 million people across the world. Whereas in the laboratory, where the variables can be more effectively controlled, the sample size and the repetition is reduced.
We test hearing defenders in this rig and in this room, and we've got so much under control, so much more than we have for the internet experiment. For example, my head is in a very precise position, the loudspeakers are in very precise positions, and they produce noise which is very well calibrated exactly for level.
Everything is controlled, right down to the temperature of the room, giving incredibly reliable data.
So we know exactly how loud sounds are being made. So in a laboratory experiment like the hearing defender test, we try and remove any variables that we can control. It's important that we know very well how these hearing defenders are wearing, because after all, it's your hearing they're trying to save.
The curriculum materials, which accompany Bad Vibes, include an activity about risk. The first part of the activity introduces ideas about the nature of risk, before moving on to risk in the context of hearing. This activity can be introduced using Professor Cox's personal experiences.
When I was younger, when I went to clubs, I used to wear earplugs, and you can buy earplugs which have got what we'd call flat frequency response. If you put normal earplugs in, they tend to make the world all very muffled, but you can buy ones from the Musicians Union which take a little bit of sound at all frequencies, and they're much better, and in fact musicians use them as well. I used to do that because I used to have quite sensitive ears. They often used to ring, so working acoustics I took evasive action, but you have to be prepared to wear earplugs, which some people might think look a bit daft.
In the first part of the activity, students are asked to rank several risks from those which they think are the greatest risks to those which are the least. So for example, dying as a result of being hit on the head by a coconut, catching flu, or losing your hearing. Students will rank the risks in small groups, say 3 or 4 at the most, and then the second part of the activity, one student is asked to pull out from the ranking the 3 risks that they are most concerned about and to be prepared to explain why they made that choice. The teacher then takes feedback from those individual students and draws out ideas of likelihood and of consequence, and also talks about students' perceived risk as opposed to what the actual value of a particular risk might be. Now, in this follow-up session, the teacher may not use those terms, might not use that language until towards the end, when students have actually, if you like, taught themselves the components of a risk and talked about perception and actual risk, even though they might not have used that language. One of the risk cards is the risk of losing your hearing, and that provides a way into the third part of the activity, where we provide students with information about noise levels that can cause damage to hearing. Students carry out a DART activity, and the outcome of that is that they appreciate that the damage to hearing is caused not only by the level of the noise but also by the length of time you're exposed to it. Now, before the DART activity, we ask students to vote on what type of activity from a list, so for example using a pneumatic drill or looking after a screaming child, which of those activities would they want to wear ear defenders for? And once they've carried out the DART activity, we ask them to vote again. Although the students will have found that going to a nightclub for quite a short period of time can cause damage to their hearing, they're unlikely, even at that point at the end of the activity, to say that they want to wear ear defenders, and that enables us to draw out ideas for people's willingness or reluctance to accept particular risks.
The second activity in the curriculum materials focuses on sound insulation. This activity develops students' skills of data collection and analysis.
One of the top 10 worst sounds was adults arguing. And this is often something that happens and can be heard by neighbours. And this can be used as a stimulus to thinking about home insulation with regard to noise. Therefore, what we've done is developed an activity which enables youngsters to carry out their own inquiry to investigate different materials for insulating against noise in your home.
The final activity, associated with the Bad Vibes film, looks at the role of the scientific community in validating changes in scientific knowledge and ideas. The process of peer review is a key element of this.
Publishing journals is very good because it's peer reviewed, so it has some checks from other people in the area, so people know it's got a certain quality. It's not a load of rubbish, there's something in it which is worth knowing about. I work as an associate editor for a journal, so I regularly have to deal with journals coming to me, being sent out to reviewers and looking at whether they're up for publication. And there's a variety of criteria people use. I suppose the most important one is there something interesting and original in the paper? Because an awful lot of people submit papers which are not up to scratch because they basically aren't new enough and we already know the answer to it. And then you're looking for other criteria, such as have they cited previous work which is in the same area? So have they actually acknowledged the work which this is all built upon? That's part of showing it's original as well, because you say, oh, you know, so-and-so did this, so-and-so did that, but I've done this and that's why it's better and an improvement on what's been done before. So these are the sort of criteria people are looking at when they review the paper. So the paper goes out, typically 2 people read it who are experts in the field. You don't know who they are. So when the papers come back, you have these comments, and sometimes they're polite and sometimes they're rude, and you then have to deal with them. Now, you don't actually have to deal with all the comments from the reviewers, because it's not necessarily assumed the reviewers are right and you are wrong, but you need to argue as to why you are right and why you're wrong. And more importantly, you need to make that argument in the paper. But you want people to know about that work, and actually conferences are by far the best way within an academic area to get people to know. So you go off to the conference and you stand up and you present on it and you chat about it, and then people can go and look up the journal paper if they get really interested in the subject.
You'll find a simplified paper of Professor Cox's research in the curriculum materials, with suggestions for how this could be used to develop students' understanding of the peer review process.